All right, we are still looking at trigonometry, part 1, episode 3. In this episode, we are looking at special angles. Special angles. Now, what are the special angles in trigonometry? These are angles that normally does not require calculator or the use of four-figure table. So the special angles are usually 0 degree, 30 degree, 45 degree, 60 degree, 60 degree, 90 degree, 180 degree, 270 degree, and 360 degree. These are the special angles that we have. Now we want to see what the trig ratios, how they behave in terms of these special angles. So first, let's say, let us look at the zero first. The zero. Let's look at 0 degree. 0 degree. So say I have this line here now. In this line, if I have A and B here, another line will leave this place. As it's coming, it will now form an angle here like this. This becomes the what? The vertical component. Then here becomes theta. So if I call here maybe C, here is the y component, here is the s component, the y component and the s component. All right, let's start from 0. I want to focus more first on 0, 90, and then probably 80 before we now look at the 30, 45, and 60. All right, let's start from 0. Now looking at 0, if theta is 0, it means this is this line, like I said, is emanating from here, so as one unit. Okay. Now, let's say theta is 0. If theta is 0, it means that this line automatically is on this line. That means there is no angle coming because it's 0. So this line automatically is on this line. We know that sine theta is opposite over hypotenuse. And the opposite here in this case here is y. Why the hypotenuse here is 1. All right, come to think about it. If this line, now when theta is equal to 0, that means sine 0 degree. When theta is not equal to 0, what now happens is that this particular AC is on this line. So there will not be any y component because the y component will not be seen because it will be on this line. So in other words, your y component at that point is 0. So it means that your y is 0 over 1. And if you divide 0 by 1, your answer is 1. So sine 0 degree is 1. Special angle of sine 0 degree is 1. Let us look at cos. Cos 0. Remember cos is what? Adjacent over hypotenuse. Adjacent over hypotenuse. Now, this time around, we are still talking about 0. When theta is now 0, so cos 0. So cos 0 now, adjacent over hypotenuse. Now, remember that this line AC is on this line. There is no y component, but there is s component. And since this AC is on this line and the AC is 1, so which means your s component is 1. So I will now have 1 over, the hypotenuse is still 1 as the case may be. So 1 divided by 1 is what? Is 1. So sine 0 divided by 1 is 0. 0 divided by 1 is 0. Sorry. So this is 0. So that is sine 0 degree is 0. Why cos 0 degree is what? Is 1. Cos 0 degree is 1. All right. Then let's talk about tan. Tan 0. Remember, tan is opposite over adjacent. Now, remember, this your AC is on this line. So y component is, this normally is the opposite, which is y. Your y component is still 0. And your s component is what? Your s component is 1 because this adjacent is on this place here. So which means opposite is 0 over 1. 0 over 1, because your s is your adjacent is 1. So tan 0, the 0 divided by 1 is 0. That means tan 0 is 0. So sin 0 is 0, cos 0 is 1, then tan 0 is 0. That is for 0 degree. So let's go to 90. Let's go to 90 degree. 90. 90. Again, in 90 degree, here is still your, in 90 degree, what now happen is that this AC that was here will now come now and form 90 degree. Now, usually, when you plot a graph, in your y-axis, all your s value is 0. And your x-axis, all your y-axis is, all your x-axis, all your y value is 0. That was why when this one was here just now, the y was 0 because it was on the x-axis. So the same thing will happen now. When we say 90 degree now, it's not forming, this line now is not formed here. Since it's formed here, there is no s gain. Your s is now 0. So still going by sine 90 degree, which is saying opposite over hypotenuse. When your theta is 90 degree now, when theta is 90 degree now, which means that your y is, because this AC now is on this line now, and the AC is 1, so your y is 1, and your hypotenuse is also 1, so this equals to 1. 1 divided by 1 is 1. So sin 90 degree is 1. Okay, so when you are solving sin 90, you know that sin 90 is 1. Don't bother yourself too much. Then cos 90. Cos is adjacent over hypotenuse. Adjacent over hypotenuse. Now, remember your adjacent. Your adjacent is your x. And remember that your s is what? Your s is 0. Your s is 0 because this line is on this line, so there is no s. So your s is 0. So your adjacent is 0 over your hypotenuse. Your hypotenuse is still 1. So 0 divided by 1, that gives you 0. So your cos 90 degree is equal to 0. So let's look at tan 90 degree. Tan 90 degree is opposite over adjacent. Opposite over adjacent. All right. Your opposite is still the y, and your y is 1. While your adjacent is the s, and in your y-axis, your s is 0, so your s is 0. So the adjacent is 0. So when you divide 1 by 0, your answer is infinity. It's undefined. The answer is undefined. So that is why if you press tan 90 degree is undefined. That's why if you press sin 90 in your calculator, it's going to tell you sign error because sin 90 degree is undefined. If you divide 1 by 0, your answer is not 0. It's undefined. All right, infinity. All right, so that is for 90 degree. You can go on and on for 180. You will see similar things there. Now, okay, let me just give you the sample of 180. How it will look like. Remember in the quadrant just now. Now, this is not the 180. 180 is on this straight line. Now, the line now comes now to this line. That line that was here now. That AC that was here. Now, it's now on this line here. And remember that here is your negative s. Here is negative x. Here is positive x. Now, when this line is on this line, and we are still looking at the same sine 180, which is opposite over hypotenuse. Remember that your opposite is that y component. And on this line of 180, because sum of angle on the straight line is 180, so your 180 is on this line now. Is on this line. So since your 180 is on this line, it means that your y here is 0, but your x is minus. Your s is minus 1 because that your line is there. So your s is now minus 1. So 0 divided by minus 1, you still get what? 0. Okay? So it means that your sine 180 degree is 0. Then cos 180. Cos 180. Cos 180, remember it is adjacent. Adjacent. Okay, the hypotenuse is the hypotenuse is 1, not minus 1. The hypotenuse is 1 because it is that line is 1, but the negative sign, this is 0. So adjacent over hypotenuse. Now your adjacent is the value of x because you're on this line. Your adjacent is value of s, which is minus, but that 1 was still there, so it is minus 1. Minus 1 over the hypotenuse, which is 1. So minus 1 divided by 1 is minus 1. So cos 180 degree is minus 1, while sin 180 is 0. Okay, then tan uh, tan 180. Tan 180. So tan 180 degree. Tan 180 degree, again, tan, as you know, is opposite over adjacent. Opposite over adjacent. Okay, opposite over adjacent. Right. Here is the opposite now. Remember that the opposite is usually the y component, and we are talking about 180. Your y component is 0. Is 0. While your adjacent is minus 1. Adjacent is minus 1. Adjacent is minus 1. So 0 divided by minus 1, you still get 0. So in tan 180 degree is 0. Sin 180 is 0, while cos 180 is minus 1. So let's go to 270. All right, 270. 270. 270 is on this territory now. Here. Now that you are here, you are now in the negative. You are now in the negative y. You are in the negative y. Okay. So if we take now, we are now talking about 270. So sine 270 times, remember here is 1. All right, and your s here. Okay, your s is, this is on the 270 line. This is on the negative y-axis. Your s is also 0 here, but your y is negative. Your y is negative. So we now have minus y over minus 1 rather. Minus 1 over 1. So sine 270 now is minus 1. So sine 270 is minus 1. Then because you know why? Because remember this line that was AC that was here is now on this line. So the 1 is here. But because this is negative, I will not carry minus 1. Yeah? Then over the 1. All right. Then cos 270. Cos 270, as you know, is adjacent over hypotenuse. Now your adjacent, your S is 0. Because your S is on this line, is 0. 0 over 1, which is 0. So cos 270 degree is 0. Cos 270 degree is 0. All right. Then tan 270. Tan 270 is, again, we know that tan is opposite over adjacent. Opposite over adjacent. So now your opposite, as we know, is the y component, which is minus 1. And your adjacent is the s component. Here, s is 0. So the s component, your s is 0 in the y-axis. So s is 0 there. And when you divide 1 by 0, it is infinity. So tan 270 is infinity. Sin 270 is minus 1. Cos 270 is 0. Tan 270 is infinity, undefined. All right. So let's look at 360. I just want to focus on those ones first before we now look at the 30, 45, and 60, because these are the ones that people don't pay attention to. That's why I'm looking at it first. So let's look at 360. 360 now. That line AC, which was here now, is now back here. The line AC now is now back here. As long as it's back here, It means sine 360 times sine 360 degree, which is, there is no y component. So your y component is on this line now, which is 0. Opposite is 0. While your adjacent is the positive 1 plus 1. So 0 divided by 1 is 0. So sine 360 degree is 0. Then cos 360 degree. Cos is adjacent over hypotenuse, that is plus 1 over 1, which is what? 1. Plus divided by plus is 1, which is 1. Then tan 360 degree. Tan is opposite over adjacent. The opposite, as you know, opposite is the y component, which is on this x-axis, and it's 0 there. That is 0 over your adjacent. Your adjacent is the s, which is positive 1. So that is 0 divided by 1 is 0. So tan 360 degree is 0 degree. So in other words, you now get all the trig ratio of 0, 90, 180, 270, and 360 degrees. So you just have to know it, even without proving it. You now know it, so that when you are solving, you will not waste time. All right. So let us now look at the 30 and 60. Then 45 will be last. Okay. To prove 30 degree and 60 degree, we normally use an equilateral triangle. Equilateral triangle, here is 2, 2, and 2. And here is 60. Here is 60 degree. And here is 60 degree. So if we share this triangle into 2 equal parts, since from here to here is 2, here will not be 1, here will not be 1, here will be 1, and here will not be a right angle. So if I call here A, and I call here B, I call here C, and I call here D. Our duty now is to find this BD using any of this triangle. Let's use this one now. So if I share here 2, here is 60, so automatically here will be 30 degree, and here will be 30 degree. Okay, 30 degree. So let's say I want to cut this triangle out. If I cut that triangle out, I will have something like this. This is the right angle. Here is your A, here is your B, and here is your D. Okay, then here is 30 degree. Here is 2, here is 1. So I have to use Pythagoras theorem to find here. Remember, Pythagoras theorem states that in a right angle triangle, you must use that word first. In a right angle triangle, the square of the hypotenuse side is equal to the square of the sum of the 2 other sides. So which means I want to get BD. So BD square will now be equal to 2 square minus 1 square. So 2, because this is the longest side, that's why I need to plus it. So it must be this minus, I'm looking for the other small side. So 2 square is now 4 minus 1, which is 3. So our BD is equal to square root of 3. So here will be square root of 3. Square root of 3. Remember, here is 60 degree. So with only this triangle alone, I can get the 30 and the 60 now. All right, so let's get it now. Let's go to 30 first. Sine 30 degree, remember it is opposite over hypotenuse. And for the 30, the opposite to this 30 is here. And the hypotenuse is here, which is 1 over 2. So sine 30 degree is 1 over 2. That is the special angle for sine 30 degree, 1 over 2. Then cos 30 degree. Cos is adjacent over hypotenuse. Now, since here the 30, this here is the opposite, here is the hypotenuse, so that's why it becomes the adjacent, which is root 3 over hypotenuse 2. So cos 30 degree is root 3 over 2 as a special angle. Then tan 30 degree, tan 30 degree, tan 30 degree. Tan is opposite over adjacent. And the opposite to 30 is 1. Adjacent is root 3. That is 1 over root 3. Or according to short form, you can say root 3 over 3. So it's 1 over root 3 or root 3 over 3. And when we do sort, we will understand there's what we call rationalization. We have to rationalize if your denominator is sort. in mathematics. I will teach you rationalization in SOD. All right. So that is tan 30. So we'll now discover now that sine 30 is half, cos 30 is root 3 over 2, while tan 30 is root 3 over 3 or 1 over 3. So let us now look at 60 degree from the same triangle now. Now, sine 60 degree, this time around, this is 60, this is the opposite of the 60, which is root 3 over, this is the hypotenuse over 2. So sine 60 is root 3 over 2, while cos 30 is root 3 over 2. Remember we did complementary angle, relationship between sine and cos. So we see that sine theta is equals to cos 90 minus theta. That is playing here now. You can see that sine 60 is equals to cos 30. Okay, now cos 60. Cos 60 is adjacent. Adjacent over hypotenuse. Adjacent. Now the adjacent, this is the 60. So here becomes your adjacent, here's your hypotenuse, which is 1 over 2. You can see that cos 60 is equal to sine 30. That relationship. Then tan 60 degree. All right. Tan 60. Tan 60 is opposite over adjacent. Where is the opposite to the 60? Is here. Where is the adjacent? Is here. So it is root 3 over 1. So root 3 over 1, which is same as root 3. So tan 60 degree is root 3. Is that clear? So let us now look at the last, which is 45. Which is 45. 45, we use an isosceles right angle triangle. An isosceles right angle triangle. All right. This is 90, here is 45, here is 45. That's also an isosceles right angle triangle. We have isosceles triangle, we have isosceles right angle triangle. So if here is A, here is B, here is C. In this case, we assign here as 1 unit, here as 1 unit. Then we have to calculate here using the Pythagoras theorem. This is the square of the hypotenuse is equal to the square of the sum of the two other sides. That means AB now, which is the longest side, what we are looking for now. So here we'll say 1 square plus 1 square. 1 square plus 1 square. 1 square is 1, which is equals to 2. So AB now will now be square root of 2. To remove this square now, you now square root this side. So here will be square root of 2. There will be square root of 2. So now we can now find the 45. So sine 45. Sine 45 degree. Sine 45 degree, we know that it's opposite any of the 45 you want to use, the same thing. That is why here the same number we assign. So if you are using this 45, here's the opposite, 1. If you are using this 45, here's the opposite, also 1. And this is the hypotenuse for both this 45 and this, because this is side facing here. So whichever way. So opposite over hypotenuse, that is 1 over root 2. Again, with what I did with tan 30 the other time, since the tan is a sod, it will be root 2 over 2. So it's 1 over root 2 over 2. Then cos 45, which is adjacent. So if we use here before as opposite, then now we are not using here the same one. So 1 over root 2. So which is written as root 2 over 2. So sine 45 and cos 45, they are the same thing, 1 over root 2 or root 2 over 2. Then tan 45. Tan 45 is opposite over adjacent, 1 over 1. 1 over 1, which is equals to 1. So tan 45 is 1. I believe we have done all the trigonometry, all the special angles. Let us do one example. Maybe I will give you one thing to do. All right, say evaluate sine 30 plus cos 30 over sine 60 over sine 60. Say evaluate without using tables. evaluate without using tables. Evaluate without using tables. Now, in this case, without using tables, so don't bother go and find press calculator, sine 30, 0.5, cos 30, 0.866. No, if you do that, you are wrong. You say evaluate without using table. Now you now ask, what is the special angle of sine 30? That was what we just proved. We discovered that sine 30 is equals to 1 over 2. And what is the special angles of cos 30? The special angles of cos 30 is root 3 over 2. And what is the special angle of sine 60? The special angle of sine 60 is root 3 over 2. So when they say evaluate a table, they will give you angles that are special angles. And it's expected that you use all these kind of values. So now let's substitute. So sine 30 is half plus cos 30 is root 3 over 2 divided by cos 60 is root 3 over 2. So you now work the LCM of this numerator. The LCM of 2 and 2 is 2. 2 divided 2 is 1. 1 times 1 is 1 plus 2 divided 2 is 1. 1 times root 3 is root 3 over root 3 over 2. Now, don't go and do 1 plus root 3. They are not like terms. So you leave it like that. They are not like terms, so you cannot add. So what we'll now do now, we'll do far to far, near to near. This one here now, they are together. This times this, they are together. And this one, they are together. Over this times this. Far to far, near to near. That is 1 plus root 3